So everybody should be setting up page 53 for Cornell notes. The title of these Cornell notes is our essential question for today, which is, how can you deduce the properties of an element by its location on the periodic table? Everybody should be setting up for these Cornell notes. So our objective today is that we're going to learn the characteristics of metals, metalloids, and nonmetals. By the end of this period, you should be able to look at that periodic table, and even if you've never heard of the element, you should be able to tell me a little bit about their properties. So like, for example, right now if I said rubidium, unless you research rubidium, you don't know what it is. You don't know what it does. You don't know its properties. But after we do our notes today, you should be able to tell me some of the properties even without looking it up online. Okay? But before we go on, let's just review very quickly what we learned last week. Last week we looked at several patterns on the periodic table. The last thing we looked at is how it's organized in periods and groups. And I told you had to remember something about periods and something about groups. So let's review what we need to remember about periods. And you can always look back to the notes from Friday. Okay? So who thinks that can tell me what we have to remember about periods? Yes?
Periods are like the periods is they're different. They go from left to right and horizontal.
Okay, very good. Want to add something to it? Yes. There's 7 periods. All right. So Ricky, can you tell us what we need to remember about periods?
Oh, they go left to right. There's 7.
There's 7. And what about the properties? They're different as we go from left to right. Always remember that periodic table of fabric. Remember, it was the different colors were from left to right, correct? All right, Abby, so can you tell us about periods again? Okay, very good. So remember, periods, there's 7 of them. There's a horizontal rows, and as you go from left to right, the properties of the elements change. So now who can tell me about groups? Yes? Good. All right, Sierra, so can you tell us about groups again? I'm sorry?
I didn't hear.
You can look at your notes. So groups.
We got the vertical, and we have 18 groups, and
Okay, so they're vertical, they have 18 groups, and they're similar. Alexis, can you tell us about groups again?
they're 18, and they're similar.
What's a group? Talk about it. So the elements' properties are similar. Alright? So remember, those are things that you need to remember, okay? So we saw on Friday that Mendeleev went through and put these elements in rows and columns by similar properties. After that was done, then they realized ended up with 3 major sections of the periodic table. Last week you went through and you colored those 3 sections. How many colors did you end up using? 3. 1 for metals, 1 for nonmetals, and 1 for metalloids, and that's what we're going to talk about today. So these metals, nonmetals, and metalloids on the periodic table are categorized based on their properties. Okay? You need to make sure that you understand or that you know where metals are, where nonmetals are, and where metalloids are. If you colored the same colors that were in the book, you colored blue for metals, green for metalloids, and yellow for nonmetals. Most of the blue were on what side of the periodic table? Towards the left. So metals are on the left side of what we call the zigzag line. If you saw those greens, they kind of made a zigzag line over towards the right side of that periodic table. So every element on the left side of that zigzag line is a metal except for hydrogen. Hydrogen is not a metal. But every other element to the left of that zigzag line is considered a metal. So I just kind of real quickly sketch a little periodic table. Here's my zigzag line, which would be my metalloids. So all the elements on this side are considered metals, except for the hydrogen, which is atomic number 1. Now, last year and the year before, so both in 6th and 7th grade, you should have talked about the properties of metals. Even if you didn't talk about the properties of metals, you come in contact with metals every day. So, what are some things that we know that metals can do? They're malleable. What does malleable mean? They can bend. They can be made into shapes. We know that metals can be made into shapes, right? Cars, okay? Your Xbox has metal in it, right? So we know that metals can be made into shapes, and that's considered malleable. What are some other things that we know metals can do? What'd you say? Luster. They're shiny. Okay. Tori? Good conductors of heat and electricity. Brian?
Can last long?
They do. They're durable, and they're durable because of their malleability. Yes. High melting point. Think about it. Every time your mom cooks and puts a pot on the stove, does that pot melt? No. So it has a high melting point. There's very few of us have access to the heat that is needed to melt metal. The only people that do that are the welders. Yes, thank you. Okay, welders have those torches. Those torches are really, really hot, so they have high melting points. All right. So for metals, all those are considered their properties. So right now, most of y'all, have y'all heard those things before? Yeah, right? You've heard all those. Those are the properties of metals. They're good conductors of heat and electricity. They're shiny and they have that metallic luster to them. They're malleable. Now, we didn't say ductile, but really, ductile goes with malleable. Malleable means they can be made into shapes. Ductile just means they can be made into a wire. Well, a wire is a shape. High melting point. Now, the one that y'all didn't say was a bad insulator. An insulator is something that either keeps heat in or cold in and keeps heat or cold out. Basically, that it doesn't allow it to move from one place to the other. So a good conductor of heat would be a bad insulator. If it's a good conductor of heat, it means it conduces heat very easily. If it's that, then it doesn't insulate. Insulate basically means that it doesn't allow it to move. So those are metals. Then, on the other side of the periodic table, we have nonmetals. So nonmetals are on the right side of that zigzag line. Now, if you colored the same color as the book, those were yellow. Okay? What can we tell by the amounts? Do we have more metals or do we have more nonmetals?
Metals.
We have more metals. So most of our elements are metals, but we do have several nonmetals, and those are on the right side of the zigzag line. And remember in science I told you always want to look at prefixes. What do you think the prefix non means? Not. So a non-metal is not a metal. So if it's not a metal, what do we know about its properties? Very good. They're the opposite of metals. Non-metal is the opposite of a metal, so the properties have to be opposite. So if we know that these are the properties of metals, then Edgar, give me a property of a non-metal knowing the properties of a metal. Good insulator. Because metals were bad insulators, right? So non-metals have to be good insulators. Abby? Low melting point. Since metals have a high melting point, non-metals have a low melting point. Okay? Yes, they're brittle. Brittle means that they break, right? Well, since metals are malleable and ductile, then non-metals are brittle. So basically, our properties for a non-metal are just going to be the opposite of the ones from metal. So the properties of those are they're poor conductors of heat and electricity, They're good insulators. They're dull. They're very brittle. They have low melting points. So our nonmetals are basically the opposite of metals. All our nonmetals are on the right side of the zigzag line except for hydrogen. Okay? So always make sure that you remember that hydrogen is on the left-hand side and that it is a nonmetal. But it's the only one. Everything else is on the right. So knowing those things, you should be able to tell me the properties of any element on the periodic table that's either metal or a nonmetal. So, for example, like I said earlier, I said rubidium. Nobody in here has researched rubidium, and nobody in here probably has any idea what it is. Okay, unless you researched it for one point in time. Alright? But rubidium is atomic number 37, it's in group 1, so it's on the left side, which tells me that it's a metal. So even though I've never read anything about rubidium, I can tell you that rubidium is a good conductor of heat and electricity. It is a bad insulator. It has a high melting point. It's ductile, it's malleable, and it's shiny. I can tell you those things just because of where it's located on the periodic table. So, Ricky, can you tell me something about fluorine, which is atomic number 9?
It's a non-metal.
Okay, so what else would you know about it without researching it?
That it's a dull.
Mm-hmm.
It's a poor conductor of electricity.
Okay, very good. Has Ricky ever researched fluorine? Probably not, right? Maybe yes, but probably not. But he can tell me that from what we just learned. Okay, JR, can you tell me something about barium, which is atomic number 56?
It's a metal.
Mm-hmm. So what type of properties does it have?
Good conductor. It's a metallic.
Okay, very good. Has he ever studied barium? Probably not. But can you tell me those things, and is he correct? Yes. So knowing these two things, you can tell me a lot of things about these elements without having to research them. Okay? Because those are just the patterns that they take. Yes, question?
Sure.
Yeah, go ahead. All right. Now, here we come to the tricky part. We have metals on the left, and we have nonmetals on the right. Then we come to that little zigzag line. They're called metalloids. Metalloids are a little tricky in the fact that I can't just come in and say, hey, Ethan, tell me something about silicon, and he can just look at his notes and tell me. He can't. I have to give him another piece of information. Silicon and all the other metalloids are a little weird. And before I go into that, let me just tell you something about one of the cousins I have. Okay? Oh, she didn't see. Alright, so my cousin, when she was younger, okay, anytime she had a boyfriend, she's older and she has a baby now, okay, anytime she had a boyfriend, well, we noticed that she would like change a little bit every time she had a new boyfriend. And we figured out that what she would do is she would try and like what her boyfriend liked. So, like, if her boyfriend liked country music, she liked country music. And then when she changed boyfriend and the boyfriend liked techno music, oh, she liked techno music. And then when she changed boyfriends and the boyfriend liked rock music, she liked rock music. So, basically, the way she was whenever she was in a relationship is she would try and like and be like the boyfriend that she had. Okay? That's how metalloids are. Metalloids act or have the properties of who they bond with. So if silicon, who's a metalloid, bonds with a metal, its properties are like a metal. If silicon bonds with a nonmetal, its properties are like a nonmetal. So with metalloids, their properties can't be distinguished until I tell you what they bonded with. Okay? So they can share either properties of metals or nonmetals, and it's going to depend on who they bond with. So if I come in and I say, okay, so silicon, he's going to look up there and says, Mr. Hernandez, you're being a little tricky. I can't tell you that yet. And he's going to say, well, you need to tell me what it's going to bond with. And then if I say, okay, well, Ethan, silicon's bonding with calcium, he's going to look over there, he's going to see calcium as a metal, and then he's going to give me the metal properties. Because silicon is going to act the same way, or it's going to have the same properties as what it bonds with. Okay? So metals and nonmetals, very easy. Those are straightforward. Metalloids, I would have to give you an additional piece of information for you to be able to tell me the problems. So, any questions? That's the end of the notes for today. Basically, by now, you should be able to answer that essential question. How can you reduce the properties of an element by its location on the periodic table? You look at it, if it's a metal, it's the metal properties. You look at it, it's a non-metal, it's the non-metal properties. Very simple. Any questions? Okay, so you'll get out 1:34, 20 minutes, 24 minutes. You have 24 minutes left in class. So what you need to do, what I'm going to let you do for the rest of the period is you're going to work on your project. But I want to say a couple things.